writing some more inequalities, particularly on number lines, and then a bit of solving later on as well. Now, before we did some of these and we represented inequalities on number lines, and they were just kind of straightforward, ended up with like x is bigger than something or x is less than or equal to something else. But we can actually put a boundary at both ends. So before, where we had just one boundary and then infinitely went off in another direction, we can actually have something like this where we've got two sides to it. And you can think of this in two steps really, that x is greater than -2 because x is this side is bigger than, isn't it? So x is bigger than that thing, so -2. So anything bigger than that, but it's also less than or equal to 3. So it's bigger than -2, but less than or equal to 3. It's sort of between these two boundaries. Now the bottom end it doesn't include. It's just anything bigger than -2, but the top end it goes all the way up to 3 and includes 3 as well, because we've got the equals sign as well. And we can represent these just like we did before on a number line using our circles. And so if it's less than or equal to or greater than or equal to, it's a filled in closed circle. So that sort of includes it. Remember I said extra ink on your sign means extra ink on your circle. Or if it's just less than or greater than, we put an open circle to show that it goes up to that number but doesn't actually include it. So this one here, firstly start with your circles. So the two numbers are -2 and 3. Those are my two boundaries. So I'm going to start with a closed circle at -2, and that's here, isn't it? There's -2. So we put a circle, an open circle, sorry, above that. And then the other boundary is 3. So I put a closed circle above that. And then instead of an arrow, this time you just join it with a line. And there you go. That's it. So you've got kind of two boundaries to our inequality this time. So let's try another one. So x is bigger than -5 but less than 3. So there we go. I start with, firstly, there's my -5. So I put an open circle because it's a greater than sign there, or less than, depending which way you think of it. Where's that come from? Let's get rid of that bit of drawing there. Get rid of that little bit there. Don't need that. Back to pen. Okay, and at the other end we've got a boundary of 3, so there's 3 on my number line. So above that, again, I'll put an open circle because it's just that symbol, it's just the less than symbol, and join them with a line. Yeah, so it's just the same as before, except we now have a boundary at each end. I would always start with the two circles first and then just draw a line between them. So there's my two numbers in my inequality. Now the bottom one is going to be a closed circle because x is bigger than or equal to -1. And at the other end it's just less than 4. So it doesn't include 4, it just goes up to 4, and then put a line between them. Cool, fair enough. Your turn. There's 4 of them. Pause the video, sketch out the number lines please with a ruler, and put them in. Put your circles, put your lines. Unpause when you are done. Okay, so you've unpaused. So my two numbers are -4. Now it's going to be an open circle above -4. And 3. And it's just less than 3, so that's an open circle again. And a line with a ruler, which I can't really do on here because there's no ruler function. But you get the idea. Yours will be neater than mine. Now, -4 is one of the numbers, and 1 is the other. Both of these will be closed circles because they include the number at the boundary there, at each edge, and a straight line between them. Okay, 0 is my first number, 5 is the second. Now 0 will have a closed circle because it's x is bigger than or equal to 0, but at the other end it will be an open one because it's less than 5, doesn't include 5, and a line across. And -5 again, and -1 is my other boundary. We'll have an open circle at -5 and a closed circle at -1 and a line between them. Okay, cool. Right, what about the other way though? So here are some written out for you. I want you to write down, pause the video and write down what the inequality is that it represents. So you will have x in the center, we'll use x for each one, and then some kind of symbol each side of it, and then whatever numbers you think you need on top. Okay, so pause the video, unpause when you have done. So unpause, the first one is x is bigger than 2 but less than or equal to 6. Okay, be careful with the circles. If you're finding you get the first couple of these wrong, I'd pause the video again and go back and just have another double check. Number 2, x is bigger than 3 and less than 7, somewhere between those two, or anywhere between those two, sorry. Next one, x is bigger than or equal to 0 but less than or equal to 6. Don't forget to mark your work, people. I've noticed send me lots of lovely photos of work, lots of which haven't actually been shown to be marked. I'm sure you are marking, just show me. Number 4, x is bigger than or equal to -3 but less than 1. 5, x is bigger than -4 but less than or equal to -1. And 6, x is bigger than or equal to 0, less than or equal to 3. Don't forget to show that you're marking. Number 7, x is greater than or equal to -5 and less than or equal to -3. Number 8, x is bigger than -8 but less than or equal to -4. And number 9, x is greater than or equal to -6 but less than -2. Last 3, x is greater than -3 but less than or equal to +3. Number 11, x is greater than -7 but less than -4. And lastly, 12, x is greater than 0 but less than or equal to 7. Okay, next skill then. Solving. So we did some solving before, and remember the solution to an inequality is a range of answers, not just one fixed solution. So we won't have an answer that just says x is 2. We will now have a range of these things. You know, x is less than 2, but also more than that, we're going to have questions like this, which can be represented on a number line just like the previous ones were, except it's kind of been fiddled with. There's some extra stuff. So just like before, I'm going to solve like I would normally do. So if you ignore the bottom part of this, just think of the 3x minus 4. I want to get that to being just x, probably with those two symbols still in place, and find out what the two things are either side of it. So do exactly what you would do normally. I would add 4 to both sides of my equation, except this time I've actually got 3 sides of my inequality to work with. I'm going to add 4 to all 3 parts to get 6 is less than 3x, which is less than 14. And then I'm going to divide by 3. So I get, 14, that should be 18. You probably noticed that, didn't you? That should be 18 on the end there because 14 plus 4 is 18. Silly me. 6 divided by 3 is 2. 3x divided by 3 is x. And 18 divided by 3 is 6. Okay, so x is greater than 2 but less than 6. So the only real thing that's different here, the new skill, is to remember to whatever you do to one part, do it to all 3 parts, just like I forgot to do here. You know, to all 3 parts of your inequality need to have the same thing done to them to keep them all balanced. This one, okay, I've got a divided by 4 in the middle here. So the first thing I'm going to do is times by 4, which will cancel out the divide by 4. But remember, what you do to one part of your inequality, you must do to all parts of the inequality. So 3 times by 4 is 12. And a half, or negative half times by 4 is -2. And then take away 3 from all 3 parts of your inequality to get x is less than 9. But greater than or equal to -2, take away 3, is -5. Okay, and the symbols, again, just like I was solving before, just use whatever symbol you are given. Let's be really clear about what our answers are. There's one answer. There's the other answer. All right, time for you to have a little go. There are 2 for you to do. I want you to sort of simplify, essentially, solve these inequalities to get them down to just being x in the center there. Pause the video, unpause when you have done. Okay, we've unpaused. So take away 7 from all 3 parts of your inequality. 7 take away 7 just leaves the 5x on its own. 47 take away 7 is 40. And negative 13 take away 7 is negative 20. And I don't want 5x, so I divide by 5 to get x. But you do that to all 3 parts of your inequality. So minus 20 divided by 5 is negative 4. And 40 divided by 5 is 8. So there's my answer. X is bigger than negative 4, but less than 8. On to the next one. Deal with the number sort of near x last, the one touching x, either dividing or timesing. We'll deal with this one first. Again, if you struggle with normal solving, I'd definitely go back and watch another video or do some practice questions. So I'm not concentrating on the solving part so much now as the inequality part. Right, 12 plus 5 is 17, because I'm thinking by now we're probably getting really good at these. Negative 4 plus 5 is negative 1. Okay, I've got x divided by 3, so I need to times by 3, and I need to do it to all 3 parts of my inequality to get x is greater than or equal to negative 3. 51. X is less than or equal to 51. Cool. Don't forget to mark. Some more for you to do then. There are 6 here for you to have a go at. Pause the video, unpause when you're done. Cool. Okay, let's take away 4 from all 3 parts to get x is less than or equal to 9. And x is greater than negative 3. B, let's take away 1 from all 3 parts. So negative 15, be really careful with those negatives. And that's 5x is greater than or equal to negative 15. That is not 13, but 15. And less than or equal to 6 take away 1 is 5. And then divide by 5. So we have negative 3, the symbol that we want, x, the other symbol, and 1. X is greater than or equal to negative 3, but less than or equal to 1. Let's add 13 to both sides. So this will turn into positive 3. So that's 3x. And on this side, 2 plus 13 is 15. And where are we? Let's divide by 3. I haven't got space to write that in. Is 5 and 1. X is bigger than or equal to 1, less than or equal to 5. Don't forget to mark. D. Add 11 to all 3 parts of your inequality. So that goes back up to negative 21, which is less than 3x, which is less than 6. Oh, no, sorry, 90. Damn me, silly me. And then divide it by 3 to get negative 7 less than x, which is less than 30. X is bigger than negative 7, but less than 30. Over here, let's take away 4 to get 5 is less than or equal to x over 2, or half x. 14 take away 4 is 10. And then I'm going to times by 2. I'm running out of space a little bit, so write that over there. So 10x is greater than or equal to 10, but less than or equal to 20. Last one. Now, the whole of this centre bit is in a fraction, so we can first of all turn it into a straight line a nice straightforward equation with no fraction in it by timesing by the 5. Negative 4 times 5 is negative 20. Negative 10 times 5, though, is negative 50. And then we're going to take away 3. Let's just put that over there so we can see that. Take away 3, which leaves x on its own. Did that sign wrong. And take away 50, and I'm going to, what was it, take away 3, that's supposed to be, isn't it? So negative 53 on this side, and negative 23 up here. Okay, so x is bigger than negative 53, but less than or equal to negative 23. Cool. Well done. Bye-bye.